Alright, so we're going to put together everything that we've done with our sine and cosine functions. So far we've talked about all of these different types of transformations. So we're just going to put all of them together. So A, the letter A is right here, and that's multiplying the trig on the outside, and that's what's responsible for changing the amplitude. So A is for amplitude. I also want to note here, if you see negative sign in front of the A, like a minus A, that also does something. So let's just note that when it's negative, it also reflects it. So the amplitude is separate from the reflection. The amplitude changes, and then if it's negative, it also reflects. And I'll be technical and say over the x-axis. Alright, next B. B is the number that you see next to the trig, in between the trig I should say, and your angle theta or x. So B is right here. It's kind of squished in between the trig and the theta. And B is responsible for changing the period. Notice I'm using the word changing. It is responsible for changing the period. It is not the period, but it is changing the period. So typically we say that the period in degrees is 360, and so B is going to change it by, if you divide it by that B, then you would get what the new period is equal to. Or if it's in radians, 2 pi over B. Okay, next H. H is inside of the parentheses, and H is responsible for our horizontal shifts. So if it's a minus sign, you'll see it go left, and if it's a plus sign, you'll see it go right. And then lastly, K is the number all by itself, and that is our vertical shifts. And up, you'll see a plus sign. Actually, you won't see a plus sign, it'll be a positive number, but down you will see that it's a negative number. Alright, so let's do our first example here. So we have y equals 3 plus 5 cosine 2 over 3 theta minus 50, and this is in degrees, which generally when you see theta it is in degrees, but we'll always put this right here for you too. Alright, so our trig here, I see a cosine, so our trig is cosine. This box is going to be given to you on a test, so I mean use this box like it's just always going to be given to you like this. Alright, our vertical shifts, we see this 3 right here, so that tells us we're going to go up 3. Our horizontal shifts is inside the parentheses, and minus actually means that we're going to move to the right. So right 150. Do we reflect? So this is a plus 5 cosine, so no, we will not reflect. Therefore, cosine will stay as that U shape you see, that upward U. The amplitude, the number in front, is a 5. And our period is going to be found using this 2/3. So in degrees, we take the typical period, which is 360, and we divide by 2 over 3. So you do have to be able to do this math. So in order to do this, I'm going to reciprocal the bottom, so 3 over 2, and let's use that magic number of 1. What I do on bottom, I must do on top. So again, the reason why we do this is this whole bottom is going to just go away because the 2 for the 2 and the 3 for the 3. Now I'm going to say this is 360 over 1. So what ends up happening is that 360 multiplies the 3, and then it also will divide by 2. So rather than doing it, I mean, you can do this however you want. So we're going to do 360 times 3, because that's right here. 360 needs to multiply the 3. So that's 0, that's 18, carry the 1 is 10. But then we still have over 2, so over 2. And so we get 540. I have a big pen, so this is hard for me to write, but hopefully you did that in a little bit smaller space than I did. So I'm going to erase all this, so if you need to pause this now, you can pause it, but hopefully you got that the period is going to be 540 in this example. Alright. So our period is 540, and then in order to get those critical points, remember that you have 4 critical points. So you take 540 and divide it by 4. This is why I don't like degrees, because it's such big numbers. You have to do all this math over here and stuff, but I know y'all don't like radians because they're pies, so to each their own. So I'm dividing by 4. 1, 4, 14 is 3, 12, 20 is 5. 135. Maybe you could do that in your head. I can't do that in my head. Okay, so we know that a period takes 540 degrees, and we have critical points at every 135 degrees. Alright. So now we're going to take all of this information and we're going to put it on our graph. So if you're going to go up, if you're going to go up 3 and right 150, when you make your XY axis kind of accommodate for that. So if you're going to go right, that's kind of the best one because you don't have to move any in the backwards direction up. So I don't need anything to the left, and I need a little bit more on the upward side of things. I'm just going to go ahead and start with my right 150. So this is 150. And how I like to do this is I just go ahead and say, well, I need 4 tick marks to complete one cycle. So 1, 2, 3, 4. This is going to be the end of my first cycle. 1, 2, 3, 4. This will be the end of my second cycle. And now we're going to use this 135 to note each one of these marks. So plus 135, 150 plus 135 is 285. Plus 135. Alright, 1, 3, 5 is 10. Carry the 1, makes 9. 12. Carry the 1 makes 4, so 420. I'm going to erase this. I don't know why I just put it there. I just totally skipped a whole bunch of stuff. This is 420. Add 135. So 1, 3, 5 makes 5. 5. 5? 1, 3, 5, yeah. Alright, add 135 again, so that makes 10. Carry the 1 is 9. 8. This is a good checking point because you can go ahead and say, well, if I'm ending my cycle, that should be able to make sense. And it doesn't, because 150 plus 540 should be 690. I don't know how I got 8 right here. So, y'all should be checking my math. I don't want to erase all of that. No, no, no. Alright guys, I'm just going to make this a 6 because it's not wanting to let me erase part of it. So this is now 690. Because if you add 135... Okay, let's keep going. 135 makes 5, 2, 8. 135 makes 10, 6, 9, plus 135 is 1095, plus 135 makes 10, 3, 1230. So a quick check once again is 690 plus 540, yes, is 1230. Alright, this is the hardest part, especially when it's these big numbers. They're not all going to be these big numbers, but for degrees they often are pretty big. Now we need to accommodate for a vertical shift. So typically your sinusoidal axis is on the x-axis. I say typically, for the parent function it's on the x-axis, but since we're going to go up 3, then I'm going to draw a new sinusoidal axis, and it's 3 up from that. So this is my new sinusoidal axis. And my amplitude is 5, which means from the 3 I'm going to go 5 up, and I'm also going to go 5 down. So I'm just going to mark 5 up, 3 plus 5 is 8, and 3 minus 5 is negative 2. You don't need to do everything in between, just those numbers is all that's really important. Alright, and cosine, we noted, it normally starts at the up, and then we make this u. So our starting place is the 150, and we're going to start up. And then you make that general shape from here. So once you know you start up, from there it's just about saying, okay, if we make a wave, I'm going to go middle, down, middle, up. This is the end of my first cycle. So now if I start at this first, starts at the up, middle, down, middle, up. And we connect. And that's our cosine graph. Alright, when you do domain and range, for domain, it's a little confusing, but I mean, really and truly, remember that this is just 2 cycles. I don't want to really actually do anymore, but it does go on absolutely forever. So domain, left to right, well, it doesn't have a leftward like stopping point, so that's negative infinity, and then as you move to the right it continues forever. So that's negative infinity to infinity for the domain. But the range is going to have a very clear ribbit bottom to top. The bottom is negative 2 and the top is 8. So the range is negative 2, and when you touch it you use brackets, so negative 2 to 8. Alright, let's go on. I'm going to go a little bit faster on this next one. So negative 5 plus 6 cosine pi over 5 x minus 2. Alright, so my trig is cosine again here. My vertical shift is down 5. My horizontal shift is right 2. I see a positive in front of my trig, so I do not reflect. Therefore, this cosine is going to be that typical u. My amplitude is 6. My period, I'm in radians, so take 2 pi and divide by that b value, which is pi over 5. Now I know y'all don't like pi, but it's really not that bad. So I need to get rid of pi over 5, so I'm going to do 5 over pi to get rid of it, but what I do on bottom, I must offset by doing it on the top as well. So the reason why I do this is pi for pi cancels, 5 for 5 cancels. Now this is actually a good example because here, this is 2 pi over 1. So on top, you have a pi, and you also have a pi on bottom. So the pi's cancel, and then all you have left is 2 and 5 on top, leaving you with 10. So our period is 10. And then if I take that period and divide it by 4, because that's how many critical points I have in every cycle, I get 5 over 2. And if you would rather use 2.5, I see nothing wrong with that. I prefer fractions. And maybe by the end of the year, you'll prefer fractions. But I'm going to use 5 over 2. If you use 2.5, that's fine though. Okay, so I need to count for an XY axis that's going to be moved down 5 and right 2. So if I'm going to go right, that means I don't need to see anything left. If I'm going to go down 5, I need to see primarily down stuff. So that's my XY axis. I'm going to go to the right 2. This is my starting place. And go ahead and make those 4 tick marks. 1, 2, 3, 4. This is the end of my first cycle. 1, 2, 3, 4. This would be the end of my second cycle. Alright, so if I'm going to do tick marks at every 5 over 2, well, since this has a denominator of 2, I'm going to change this to a denominator of 2 to make it 4 over 2. So when I add 5 over 2, now I'm at 9 over 2. If you're using the decimal, that's 4.5. If you add 5 over 2, that's 14 over 2. That's the 7 if you're not using the fractions. 19 over 2, 24 over 2, that's 12. Which makes sense, because if this was 2, then when you add 10, you should get 12. Alright, so maybe decimals was easier in this one. 29 over 2, 34 over 2, 39 over 2, and add 5 over 2 one last time is 44 over 2. Alright, so if you want to check really quickly, this is 2, 2.5, 7, 9.5, 12, 14.5, 17, what is that? 19.5 and 22. Alright, let's go ahead and do our vertical shift down 5. So if I'm going to go down 5, that's here at negative 5. And my amplitude, oh, let's go ahead and draw the sinusoidal axis. Just so that you can kind of see where the wave is supposed to go about. And the amplitude is 6, meaning from the 5 you're going to go 6 up. So negative 5 when you add 6 is 1. And then you're going to go 6 down to get to negative 11. Alright, and now we're ready for our graph. The graph is the easy part. It's all this stuff to get there. So we're going to start up, and then from there you make your wave. So if you start up, then you go middle, down, middle, up. And that's why I like to box these things, because then I know if I start it up when I complete my cycle, that should be at the up too. Alright, middle, down, middle, up. And we connect, and this is our graph. Alright, so once again, domain is all real numbers, negative infinity to infinity. And our range, we go as low as negative 3 and as high as 1. I think on your homework, they ask a question about vertical shift, so let me just talk about that really quickly. Not vertical shift. We know what the vertical shift is. It asks a question about total vertical distance. So total vertical distance is from the highest point to the lowest point. What is that total vertical distance? So from negative 11 to 1, I almost said the answer. Negative 11 to 1 is a total vertical distance of 12. Now, a lot of people just say, well, I know that if the amplitude is 6, then when you go 6 up and you go 6 down, that's how you also get to 12. Either one of those ways of thinking total vertical distance is fine. So this number is the total vertical distance, if your homework asks about that. I can't remember, but I think it does. Okay. All right, let's go on to the next page. All right. 5 minus 2 cosine. These are all cosine. 1/4 theta minus pi. All right. So trig, once again, is cosine. We're going to have to change that last one to sine because I'm getting tired of doing cosine. But we'll do this one as cosine still. So trig is cosine. My vertical shift is up 5. My horizontal shift is right pi. I'm in radians again. Okay, look at this. I do reflect because of that minus right here. Your trig is negative, so yes, I do reflect. So cosine, that's normally this u, when you reflect it, is still going to be a u, but it's an upside down u. So that's what you should put here. It's just an upside down u. That's starting. This is really just, I mean, the box is for your information. So that's what I put for start, is what it's going to look like when you start. You start at the bottom and then you go around. Amplitude is 2. Period. Alright, so in radians, typically a period is 2 pi for the parent function, and I'm going to divide it by 1/4. Well, in order to get rid of 1/4, I do 4 over 1, top and bottom, and I end up with just 8 pi, which is a nice, easy, pretty number. When I divide that by 4 to get the critical points, I get 2 pi. Alright, so let's take all that information and graph it. So I need to account to go up 5 and right 2. So if I'm going to go up 5 and right 2, so once again I don't need to see anything left, and to go up 5, I'll show a lot of the upward stuff. Alright, I'm going to start with moving right pi. So this is my starting place of pi. And I have 1, 2, 3, 4. This is the end of my first cycle. 1, 2, 3, 4. This is the end of my second cycle. And every critical point is pi, 2 pi apart. So this is 3 pi, 5 pi, 7 pi, 9 pi. Just a quick check. Pi plus the period of 8 pi ends at 9 pi, so that's good. 11 pi, 13 pi, 15 pi, 17 pi. Alright, let's do our vertical shift up 5. And an amplitude of 2 ends at 3 and 7 then. Alright, now when we do our cosine, come back to your little reminder, we're going to have to start down this time because of that reflection. So when I do my cosine, I'm going to start at the bottom, and then I'm going to go up, middle, up, middle, down. Middle, up, middle, down. And I connect. Alright, our domain is all reals. Our range is from 3 to 7, so y'all can fill that in. Let's go on to number 4. I am going to change this to sine because y'all need to practice sine. So change this, just pretend like all along it was sine. I think this problem should be sine. So our trig is sine because I'm changing it. That's not how you do problems or anything. I just need us to practice sine. Alright, our vertical shift is down 12. Our horizontal shift is left 4. Remember that when you see a plus sign, it's actually left. And we're in degrees right now. I am going to reflect this sine. So sine is typically this S shape. So when you reflect it, now you still start in the middle, because when you reflect middle over the middle, it's still on top of itself. But now you're going to go down and then around like that. So that's what I'm going to draw here. It's still an S shape, but you're going down first instead of up. Alright, our amplitude is 20. That's a big amplitude. Our period, so in degrees, we take 360 and we divide it by 30. So this is a nice pretty number. You can cancel O for O. 36 divided by 3 is 12. And then when you divide that by 4, you get 3. So these are actually nice, really pretty numbers for us this time. Alright, so you need to make an XY graph that accounts for going down 12 and left 4. So you do need to see a little bit of the left, so leave some space over there to the left. And we're going to want to see a lot of the stuff downward. So if we're going to start left 4, then we're starting at -4. Now, when you go left, these are a little bit harder because you can't just start going 1, 2, 3, 4. You have to know where you're going to cross the x-axis. So you kind of have to think ahead of time. Our critical points are going to be 3 apart. So when I add 3 that first time, I'm going to be at -1. Then when I add 3 the next time, I'm going to be to positive. So you're going to go 1, 2, 3, 4. You kind of got to be able to know where that y-axis is going to fall. Alright, this is the end of my first cycle. 1, 2, 3, 4. This is the end of my second cycle. So let's go ahead and add 3. That's -1, 2, 5, 8. That makes sense because -4 and 8, +8, are indeed 12 apart. 11, 14, 17, and 20. Alright, we're going to go down 12. And this is our sinusoidal axis. And the amplitude, 20. So when you add 20, you go all the way up to 8, positive, and all the way down. I'm going to extend this line just a little bit to, what am I doing? Subtracting 20 to -32. I made this one really big. Alright, and let's come over here. What does it look like again? So we start at the middle, then we go down and around. So we're going to start at the middle. I am really sorry about that. That's not there. So we're going to start at the middle, and then we go down. So what I'm doing here is I'm going to that -1. I'm not using the y-axis because the y-axis is not part of my critical point. So I'm going to use the -1, and then the 2 is the next one. This is my next dot. And then the 5 is where I go all the way up, and then the 8 is where I go back to the center. If you want to go ahead and draw this first cycle, since this is our first sign, we can draw that in just so you can see that what that first cycle looks like. So sine is reflected, so that's why we're going down first, around, and back. Alright, let's finish the other cycle. So go down again, back to the middle, up, middle. So this is my second cycle of my sine. Alright, and so my domain is still all reals because we are continuing forever. We just don't, I of course, not ask you to do all that. So our domain is negative infinity to infinity, and our range is we go as low as negative 32 and as high as 8. Alright, and that's it for our notes.